Welcome friends, this is Atanu Chaudhary of SureSolve. Continuing from the first part, in the second part of the video, we'll solve the last 5 questions of SCC CGL solution set 40 on trigonometry 4 from suresolve.com. Let's solve the first problem. Question 6 is, in a right angle triangle ABC with right angle at angle ABC, if AB equal to 2 root 6 and AC minus BC equal to 2, then sec A plus tan A is option A root 6 by 2, option B 2 root 6, option C root 6 and option D 1 by root 6. The figure representing the problem is, as both the given expressions involve lengths of sides, we'll take the direct approach of using Pythagoras theorem to find the lengths of sides and then express sec A and tan A as trigonometric ratios of the sides of the right angle triangle. We have in the right angle triangle ABC, AC minus BC equal to 2. Multiply both sides by AC plus BC and you get AC square minus BC square equal to 2 times AC plus BC. Or AB square equal to 2 times AC plus BC. Because by Pythagoras theorem, square of height plus square of base equal to square of hypotenuse. Here AC is the hypotenuse, BC is the base and AB is the height. So AC plus BC equal to half of 2 root 6 whole square equal to 12. Add this with AC minus BC equal to 2 and you get 2AC equal to 14 or AC equal to 7. And subtracting you get 2BC equal to 10 or BC equal to 5. So sec A equal to AC by AB equal to 7 by 2 root 6 and tan A equal to BC by AB equal to 5 by 2 root 6, so that sec A plus tan A equal to 12 by 2 root 6 equal to root 6. Answer is option C root 6. A simple quick solution. Let's solve the next problem. Question 7 is, if tan 2 theta multiplied by tan 4 theta equal to 1, then the value of tan 3 theta is option A root 3, option B 0, option C 1 by root 3 and option D 1. We will find the actual value of the angle itself using complementary angle trigonometric function relations. We have tan 2 theta multiplied by tan 4 theta equal to 1 or tan 2 theta equal to 1 by tan 4 theta equal to cot 4 theta. From complementary angle trigonometric function relations you have tan pi by 2 minus theta equal to cot theta and vice versa, where theta is an acute angle. So tan 2 theta equal to cot 4 theta equal to tan pi by 2 minus 4 theta. Or 2 theta equal to pi by 2 minus 4 theta. Or 6 theta equal to pi by 2 equal to 90 degree. So 3 theta equal to 45 degree and tan 3 theta equal to tan 45 degree equal to 1. Answer is option D 1. Easily solved in mind. Next problem then. Question 8 is, if sin pi x by 2 equal to x square minus 2x plus 2, then the value of x is option A 0, option B minus 1, option C 1 and option D none of these. We discover the key pattern in the RHS of the given expression. We reorganize the RHS as sin pi x by 2 equal to x square minus 2x plus 2 equal to x minus 1 whole square plus 1. For any real value of x, the square of some term will be positive, and it will make the value of the RHS larger than 1. This is not possible for any value of a sine function which is the LHS of the equation. So, the square term must be 0 and x equal to 1. Answer is option C, 1. Solve quickly in mind by applying basic algebraic and trigonometric concepts. Let's take on the next problem. Question 9 is, if 2 sin theta plus cos theta equal to 7 by 3, then the value of tan square theta minus sec square theta is option A 0, option B 7 by 3, option C 3 by 7, and option D minus 1. As a rule, we examine the target expression first, and this time it gave us a solution in one step without involving any complexity of using the awkward given expression. Tan square theta minus sec square theta equal to tan square theta minus in the brackets 1 plus tan square theta equal to just minus 1. Answer is option D, minus 1. Use of the given expression is completely bypassed in this instant solution. We have followed the golden rule of target expression simplification first before using the given expression. Let's solve now the last problem. Question 10 is, if r cos theta minus root 3 whole square plus r sin theta minus 1 whole square equal to 0, then the value of r tan theta plus sec theta divided by r sec theta plus tan theta is option A 4 by 5, option B root 3 by 4, option C root 5 by 4, and option D 5 by 4. While analyzing the problem, the very first thing that strikes us is the presence of zero sum of square terms. By the principle of zero sum of square terms, we know that each of the square terms must individually be 0 for the sum to be 0. So we have the breakthrough at the very beginning. So, r cos theta minus root 3 whole square equal to r sin theta minus 1 whole square equal to 0. Or r cos theta minus root 3 equal to 0, or r cos theta equal to root 3, and r sin theta minus 1 equal to 0, or r sin theta equal to 1. As sin 30 degree equal to half and cos 30 degree equal to root 3 by 2, we deduce easily that r equal to 2 and theta equal to 30 degree will satisfy the two equations nicely. Let's show you. Squaring up the two equations and adding r square multiplied by sin square theta plus cos square theta equal to r square equal to 4. Or r equal to 2. Substituting this value of r in any of the two equations, we get the value of theta as 30 degree. Using these values of r equal to 2 and theta equal to 30 degree in the direct expression, we have the simplified direct expression as E equal to 2 tan 30 degree plus sec 30 degree divided by 2 sec 30 degree plus tan 30 degree. Equal to 2 by root 3 plus 2 by root 3 divided by 4 by root 3 plus 1 by root 3. Equal to 4 by root 3 divided by 5 by root 3 equal to 4 by 5. Answer is option A, 4 by 5. Though a few of the problems look difficult at first, but finally with suitable concepts and methods all could be solved in quick time. To read the detailed solutions, refer to the article in suresolve.com. Link is in the description of this video. And please do subscribe to our channel for latest uploads. Thanks for watching.